Okay, this video is on metamorphic rocks, and metamorphic comes from two Greek uh, prefixes or roots, meta meaning form, and morph meaning change. And you'll hear or probably understand metamorphism more from butterflies and cocoons and chrysalis. And when we take a look at the rock, the original rock is the parent rock, and the new rock that is there is going to be the daughter rock. And when we take a look at metamorphism, metamorphism is changes because of heat and pressure, not melting. Melting gives us igneous, heat and pressure gives us metamorphism. And heat can come from two different types. One is from magma. So any place we have magma, magma is liquid or melted, but right next to it, we are going to have enough heat to form metamorphic rocks. The other is going to be a geothermal gradient. So if we take a look at underneath a mountain, deep down underneath it, as you go, that heat and pressure is going to build and build and build and build. So one is near magma, and then the other one is going to be deep underneath the earth. And when we take a look at the types of heat and pressure, or more pressure, we have two unique types. We have uniform pressure, and uniform pressure is going to take and squeeze something in all directions. It's going to be uniform, not directed, and it's making everything just smaller. And the other one is going to be directed pressure, where it is squeezed or compressed. And this is where the minerals are going to align themselves. And that'll give us the difference between foliated and non-foliated. So with that, we have two different types of metamorphism. We have contact metamorphism and regional metamorphism. Contact metamorphism is going to take place along the edge of magma. And that's where the contact comes into play, that it is going to come into contact with magma and it's going to be hot. The other is going to be regional metamorphism, and that's going to take place underneath a mountain range. It's going to take place over a huge or a large area. If you ever watch a video on the Grand Canyon, they will talk about rocks that are in the bottom of the Grand Canyon that are metamorphic. And the reason why they are metamorphic is because at one point in time there was a mountain above the Grand Canyon. So it's that combination of there was a lot of rocks up above it at one point in time, and then it's so deep that that's how the depth at which metamorphism would have taken place. So an igneous intrusion is any time we have magma going into another type of rock. So here we have magma going into limestone. And when limestone metamorphizes, it's going to create a couple different types of rocks. But for the most part, we're just going to call it marble. We don't look at serpentine and garnets and that. They are in there, but for the most part, we're going to say limestone will metamorphize into marble. Regional metamorphism is going to take place over a large area underneath mountains, and this book talks about shields, or when we take a look at shields, shields are the remnants of old land. So here is the Canadian shield, and the unique thing about the Canadian shield, although it doesn't really look like it, there is a portion of the Canadian shield in Minnesota, and that's in Morton, Minnesota, and that is where you will find Morton gneiss. And there's a park there that you can go down into. I've only been there once. But there's a creek that goes through there, and you can bend over and you can pick up Morton gneiss, and that is really, really old rock. So foliated means that you can see distinct lines. or that the pressure has squeezed it so that the minerals are going to start forming in that particular fashion. And non-foliated is formed under uniform pressure, and you're not going to see the distinction. So here's non-foliated, and here's foliated. And when we take a look at foliation, this is where our foliated rocks are going to be our slate, our schist, and our gneiss, and our non-foliated are going to be our quartz and our marble. So foliated is where you might be able to see lines, or you can envision them, because with slate, the lines aren't necessarily there yet. So when we take a look at foliation, it happens, and this is what's really unique, it happens as it goes. So you can have, let's say we start with shale. Shale is going to be a sedimentary rock. You take and start squeezing shale, and it's going to foliate into a slaty texture. And if you continue to squeeze it, it's going to turn into a phylitic texture. Now, in 8th grade, we're not going to distinguish between these two because in my eyes, they're just too close. So phylitic is not going to be one that we have to choose from. So if we take shale or mudstone, and not necessarily sandstone, and we start squeezing it, we end up with slate, and then it's going to turn into phylitic. Then if we continue, it's going to turn into schistose or schist, and then it's going to turn into gneissic or gneiss. And each step of this, the foliation is going to get a little bit bigger and a little bit more pronounced. And here's slate, and here's phyllite. And to me, there's not a big enough difference between them. So we will start off with slate. And if you, well, let's start off with shale. Shale, once again, is a sedimentary rock made up of mudstone and claystone and all of those. And if you start squeezing it, we get slate. Then we get schist. And then we get gneiss. Okay. And if we have non-foliated rocks, we have marble. So marble is metamorphized limestone. And kind of my stupid way of remembering marble is white, and marble came from limestone, and limestone came from shells, and shells are white. Now, limestone isn't necessarily white, but it came from shells, and the shells are. Quartzite is metamorphized quartz or sandstone. And when we talked about though these foliated ones, we can't start with sandstone because most of the time sandstone is quartz, and it's a particular mineral. It's only one mineral. It's not a mixture. So quartzite is metamorphized sandstone. And quartzite comes in different colors. Around here, we'll talk about that, but around here right now, New Ulm quartzite is purple. So to recap, that idea that if we start with shale, shale will turn into slate, and under more pressure, we're going to skip phyllite, and we're going to say it turns into schist, and we give it more heat and pressure, it's going to turn into gneiss. And we keep on adding heat and pressure, heat and pressure, heat and pressure. It's probably going to melt at some point in time. So gneiss is the end of the metamorphism when we take a look at foliation. So that is Metamorphic Rocks. Have yourself a great day.